According to me, this question of JEE Advanced 2022 Paper 2, this question of probability is a ambiguous question because there are two interpretation of this question. See, in this question it is given that consider 4 boxes where each box contains 3 red balls and 2 blue balls. Assume that all the 20 balls are distinct. In how many different ways can 10 balls be chosen from these 4 boxes so that from each box at least 1 red ball and 1 blue ball are chosen? One interpretation of this question is you have to find the number of ways of choosing 10 balls from these 4 boxes so that from each box at least 1 red ball and at least 1 blue ball are chosen. And other interpretation of this question is from these 4 boxes we have to choose 10 balls so that from each box at least 1 red ball and exactly 1 blue ball are chosen, because only information given is 1 blue ball. But when I did this question, I found that if I use the interpretation at least 1 blue ball are chosen, then I get the answer 21816. But if I take the interpretation that we have to choose 10 balls from these 4 boxes so that from each box at least 1 red ball and exactly 1 blue ball are chosen, according to that interpretation the answer is found to be 9504. But it is not that, because 9504 is not any choice, hence I must take the interpretation at least 1 blue ball, because in examination the student doesn't have time to do both the type of questions and check. This is a mistake of examiner. He should clearly specify that about blue ball what he wants to ask. Exactly 1 blue ball is chosen or at least 1 blue ball is chosen. Let me tell you once again, the answer which is there in the choices, according to that answer the interpretation is at least 1 blue ball is chosen. That is why I am saying that this is ambiguous question. But still, for your clarity, I will do both the questions. Once I will suppose that the question written is at least 1 blue ball is chosen, and this question again I will do in 2 ways, and then I will take the interpretation that exactly 1 blue ball is chosen, and again that question also I will do in 2 ways. That is, in total there will be 4 solutions in this video, hence it will be a bit lengthy video because of containing 4 solutions of this question. According to first interpretation, suppose it is written that at least 1 blue ball is chosen, and according to this interpretation the answer is there in the choices, and that choice is A. And according to this interpretation, if I do it, first solution, suppose this is the bag 1, bag 2, bag 3 and bag 4. First, second, third and fourth. You must take care that it is given that all the 20 balls are distinct. There are 3 red and 2 blue balls in this, 3 red and 2 blue balls here, 3 red, 2 blue ball here, 3 red and 2 blue ball here. And because according to question at least one red and at least one blue ball must be chosen from each bag, and in total we have to select 10 balls. Now after choosing at least one red and at least one blue ball from all the bags, 8 balls would have been chosen, and after 8 balls, remaining 2 balls which are to be chosen, those can come from single bag also. Those 2 balls can come from different bags also. I'm taking the case that both the balls are coming from the bag number 1. And now once we have supposed that 2 extra balls are coming from the bag 1 only, those 2 extra balls can be both red or one red, one blue. Note that one red and one blue ball already have been chosen, and therefore remaining 2 balls can be both red or one red, one blue. Therefore from the bag 1, number of ways will be containing 2 parts. Note that from bag 1, 4 balls have to come out. Therefore they can come in this way: 2 red and 2 blue, that is 3C2 into 2C2, or 3C3 into 2C1. Or in simple way I can say, out of 5 balls, any 4 balls have been chosen. This is same as this. And from remaining 3 bags, the number of ways of choosing balls will be 3C1 into 2C1, 3C1 into 2C1, 3C1 into 2C1. That is number of ways of choosing 10 balls, such that 4 balls have come from first bag and 2 balls have come from second, third and fourth bag. For that, number of ways have been this, that is 5 into 6 cube, because 5 3 4 is 5 and this is 6 6 6. And similarly this many cases will be there when 4 balls have come from second bag. Similarly this many cases will be there when 4 balls have come from third bag, and similarly for fourth bag. Therefore total number of ways of choosing 10 balls, such that 4 balls have come from one of these bags and 2 balls have come from remaining 3 bags, will be this plus that is 4 into 5 into 6 cube number of ways. And now let us take the second possibility, that 2 bags have given 3 balls and remaining 2 bags have given 2 balls. To deal with this case, let us suppose that these 2 bags have given 3 balls each and these 2 bags have given 2 balls each. That is 3 3 2 2. And when I have supposed that this bag has given 3 balls, that will contain either 2 red, 1 blue, or 1 red, 2 blue. That is 3C2 into 2C1 plus 3C1 into 2C2. Agreed, it is correct, but the better way of saying the same thing is any 3 from 5, but rejecting that case when all the 3 are red, that is 3C3. Whether you write this thing or you write this thing, both are same. 5C3 means out of these 5 balls, any 3 have been chosen. But in the 3 balls chosen, one case that all the 3 balls chosen are red, that case I have rejected. That is why 5C3 minus 3C3 and 3C3 is 1. Therefore, it becomes 10 minus 1, that is 9 ways. Clearly, it is also 6 plus 3, 9. Similarly, there are 9 ways of choosing 3 balls from this bag also. And from this bag, 2 balls can be chosen in this way, 3C1 into 2C1, and from here also 3C1 into 2C1. Therefore, number of ways of choosing balls such that 3 balls from first bag, 3 balls from second bag, 2 balls from third bag, and 2 balls from fourth bag. Number of ways will be 9 into 9 into 3C1 into 2C1 into 3C1 into 2C1, that is 9 square into 6 square. But again, note that these 4 numbers can be arranged at these 4 places in 4 factorial by 2 factorial number of ways. That is, one more possibility will be 3 2 3 2. One more will be 3 2 2 3. And in this way, this many ways are there of arranging these 4 numbers at these 4 places, and therefore total number of ways of choosing balls such that 3 balls from one bag, 3 balls from one more bag, 2 balls from next bag, and 2 balls from last bag. For that, number of ways will be this into this. That is, I will get 9 square into 6 square into 4 factorial by 2 factorial number of ways. That is 9 square into 6 square into 6 number of ways. Hence, total number of ways for the given condition of the question to be satisfied becomes sum of this and this. That is, you will get total number of ways will be 9 square into 6 cube plus this case, that is 20 into 6 cube, that is 101 into 6 cube, that is into, that is 21600 plus 21661. Hence we have got A as the correct choice. And now I will say about second for understanding the second alternative solution. Note that in this solution also, I am supposing the case that at least one red ball and at least one blue ball are chosen from every bag. To understand this way, first I make you understand a simple question of this type. Say suppose these are the boxes and I have to place 9 A's, that is 9 A letters in these boxes such that every row should have at least one letter. Note that there are so many ways of doing this question, but to understand this alternative solution, the way I will be using here, the same way I will be using in the alternative solution also. It's not difficult to see that number of ways of filling these boxes by the 9 letters such that every row should have at least one A will be given by in 3C1x 3C2x square C3x cube into here 2C1x 2C2x square into 4C1x 4C2x square 4C3x cube 4C4x bar 4, and similarly for this row also same thing will come, that is, and for last row 3C1x 3C2x square plus 3C3 x cube will be there. Here same thing will be coming as this. If you are not being able to understand the reason of it, then I would say that please make your concepts of chapter of permutation combination to be strong. Just for clarity purpose, had I told that first row should have at least 2 A's, in that case this term would have been rejected. Had I told that in this row it is allowed that no any A come, in that case 4C0 plus will come. These things you would have been understanding if the concepts of chapter of permutation combination are strong. How I will calculate, that is a different part. The main thing is why the coefficient is representing the number of ways of putting 9 A's in these boxes. This is the main thing. And using the explanation which I just gave you, using that explanation, if I want to choose 10 balls from these 4 boxes such that among these 10 balls 6 are red and 4 are blue, number of ways will be equal to the coefficient of r to the power 6 b to the power 4 in the expansion of 3c1r plus 3c2r square 3c3r cube into whole to the power 4 into 2c1b plus 2c2b square whole to the power 4. Similarly, number of ways of choosing 10 balls such that among the 10 balls 5 red and 5 blue balls are there, and the condition is same that every box is giving at least one red and at least one blue ball. For that, number of ways will be coefficient of r to the power 5 into b to the power 5 in the expansion of the same thing. And lastly, number of ways of choosing 10 balls such that 4 red and 6 blue balls are there in the selected balls. Number of ways will be coefficient of r to the power 4 into b to the power 6 in the expansion of the same. That is, in other words, we have to find the sum of the coefficients of the term r to the power 6 b to the power 4 and coefficient of r to the power 5 b to the power 5 and coefficient of r to the power 4 b to the power 6 in the expansion of this. Sum of the coefficient of all these three terms will be giving you number of ways of selecting balls under the given condition given in the question. And now this can be written as r to the power 4 b to the power 4 3 plus 3r plus r square to the power 4 2 plus b whole to the power 4. That is, in other words, we have to find the sum of the coefficients of r square, rb and b square in the expansion of this. Now this can be written as 3 plus r into 3 plus r whole to the power 4 into 2 plus b whole to the power 4. Note that we are going to find the sum of the coefficients of r square, rb and b square. This is equal to 3 to the power 4 plus 4c1 3 cube into r into 3 plus r 4c2 3 square into r into 3 plus r whole square and 2 to the power 4 plus 4 into 2 cube into b plus 6 into 2 square into b square agreed that previous way was better. This way I am giving you just as an alternative, because I have found that there are few situations where this way is easier to use. But presently, the previous way was better. And now I'm completing it. It is equal to 81 plus 108 R into 3 plus R plus 54 R square into 3 plus R whole square, and remaining terms are useless because in others R cube etc. will come. Those are of no use to us. And similarly here 16 plus 32b plus 24 b square, and other terms are useless because in other terms b cube etc. will come. We are concerned with terms of r square, rb and b square only. And further it is 81 plus r plus 108 r square plus 54 into 9 r square, because remaining terms will be containing r cube etc. Those are of no use to us. And here 16 plus 32b plus 24 b square, that is equal to 81 plus 594 r square, 16 plus 594, and therefore the coefficient of b square will be 81 into 24. Coefficient of rb will be 324 into 32 plus coefficient of r square will be 594 into 16, and it is equal to 21816. Hence I can say A is the correct choice. Agreed, first solution was much better than the second solution, but second solution also had its importance because I have found that there are places where second solution is easier to use. And now again I am doing the same question under the interpretation that exactly one blue ball is chosen, and in this supposition when 10 balls have to be chosen can happen in two ways, that one box gives 3 red balls and other 3 boxes give 1 red ball each, or the second possibility is 2 boxes give 2 red balls each and other 2 boxes give 1 red ball each. Let us deal with the first case, when exactly one box gives 3 red ball and remaining 3 boxes give 1 red ball. If first box gives 3 red balls, that can happen in 3C3, and 1 blue ball means 2C1, and for other 3C1 into 2C1, 3C1 into 2, that is will be getting 2 into 6 cube, that is 432. That is 432 cases are there when first box gives 3 red ball and 1 blue ball. Other 3 boxes give 1 red and 1 blue ball. But the same thing can happen with second box also. That is, second box gives 3 red and 1 blue ball. Other 3 boxes give 1 red and 1 blue ball each. And same thing can happen with third box also. Same thing can happen with fourth box also. Therefore, total number of ways in this case will become 432 into 4. And next possibility, when 2 boxes give 2 red balls and remaining 2 boxes give 1 red ball, and for blue ball, as given in the question, all boxes are giving 1 blue ball. Let us deal with the case when first and second box are giving 2 red each. In that case, number of ways will be 3C2 into 2C1 into 3C2 into 2C1 for this, and 3C1 into 2C1 into 3C1 into, that is 6 to the power 4, because 3C2 is same as 3C1. But this is the case when these two have given 2 red, 2 red. This is the answer for this way of selecting. And these four things can be arranged at these 4 places in 4 factorial by 2 factorial, 2 factorial number of ways. Hence, total number of ways will become 6 power 4 into 4 into 3 into 2 into 1 by 4, that is 6 to the power 5. Hence, total number of ways will become sum of this and this, that is 6 to the power 5 plus 432 into 4. But it is better to write 432 as this only, because it will make calculation easier. 6 to the power 5 plus 2 into 6 cube plus into 4, that is 6 cube common equal to 6 cube into 6 square plus 8, that is 6 cube into 44 equal to 9504. And under this interpretation, in second alternative solution, using the same argument as I told in the previous interpretation, in this case you will be just finding the coefficient of r to the power 6 b to the power 4 in the expansion of this, that is coefficient of r square in the expansion of this, that is 3 plus this This is equal to 3 to the power 4 plus 4c1 3 cube into r into plus 4c2 3 square into r into and remaining terms are useless because in those r cube and higher power will come. And here I will be writing only 2 to the power 4 because b is of no use to us. I have to find just the coefficient of r square. Even this is also useless. And the term r square will be 4 into 3 cube into r square plus 6 into 9 into 9 r square. Remaining all terms are useless and outside is 2 to the power 4. That is the coefficient of r square will be 4 into 27 plus 6 into 81 and outside 16 plus 9.04.